And today, we will be learning about parallel lines and proportional parts. Oh, yeah, and speaking of which, this is one of my late live streams, so I think it's 3:17 right now, because I wasn't able to do it this morning because I was real busy doing stuff. So, now I'll be able to do 7-4 of my students. I don't think I have class right now. Technically, this is 7th period for my students. I'm just doing my normal first period talk with my students for my algebra 1 class tomorrow. I'll be doing another live stream at 4:30, I think. 4:30. Depending on how long my live stream gets today. Okay? Yes, and as you all see, I got a haircut on Tuesday night, I think. Either Tuesday or Wednesday night. Okay. So, just as a reminder of what we're going to be doing today, we are going to be doing the geometry lesson 7 for parallel lines and proportional parts. So, if you have any questions, comment down below. And if you're confused, type it down in the comments. Make sure you leave a like and subscribe. Okay? Let's go for it. And I just gained 1 like. Okay, thank you for liking. Make sure everybody subscribe. So, I'll remove my fan here. This is live number 14 of my mathematics series. Wait. I have playlists for every single one of my classes. So, okay. So, if you have any questions, comment down below. I will make sure I'll answer every single one of your comments, okay? And I already have 16 views of 2 likes. Let's get going. Okay, so, speaking of which, this geometry lesson. Okay, so if you have a geometry teacher at your school, but the where at Monoi, Brazil. What the? Yeah, I could tell that's a Brazilian flag with green. Oh no. Okay. Just, yeah, no flags. There's a Brazil, 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 and then the other one says Brazil 9 times. Which is Brazil to the 9th power. Okay, let's get going. So, I do not want to keep you all distracted. You cat's eye? No! No. I'm not cat's eye. Wait. Yeah, I do not know if this is Brazilian or not. So, let's get going. So, it's only Manawi. Okay. Pale pink. Just as a normal reminder, I like wearing pink on Fridays, okay? Every time that I wear pink, it is a Friday. So, I got pink and black and purple, I think. my shirt because I kind of like wearing pink. Okay, let's do it up. Okay. Okay, let's get going. I'm gonna get my things ready to take notes. Here's the purple. And I think I need red, blue. Okay. Oh yeah, I'm at 252 subscribers. Okay. This is like so crazy. Oh shoot, I need orange. Yeah, I don't even remember where I was going from the vocabulary. Body to the sea line dance. No! Yeah, I'm here to teach geometry, not to do a sea lion. But speaking of which, okay. So here's what we're going to be doing. Triangle. Proportion. Ality. Theorem. New sub. How old are you? I don't not normally show my age, okay? Will you remember me in 5 years? 2031. I don't know. Because all I know is that in 5 years will be 2031. Which in that case, I'll be an adult by then. And speaking of which, okay. Yeah, no jokes, no 6-7s, okay? Okay. Okay. So, I'm kind of getting myself distracted. So if I'm getting you guys distracted, so let's see. 4, 2, 2, 2. I'm fine with numbers like 4, 2, 2, 2. Okay, so if a line parallel to one side of a triangle plus for my 10 years. What 10 years? Triangle plus intersect, triangle and intersect the upper two then it divides the sides into segments. Of proportional lengths. I think that's okay. So here is an example of triangle proportionality theorem. Okay, so I'm a male. I like wearing pink on Fridays. Don't judge me. Thank you. So, example. If segment BE is parallel to CD, then segment AB, divided by MBC is equal to MAE divided by ED, sorry. MED. Oh, we have a new person. Fan HDU5. Okay. Hi. I do not live in the UK. Sorry. I'm from the United States. Thank you very much. I kind of look like I'm Canadian, but I'm not Canadian. I'm born in I'm American, United States. So, okay. So let's see. We have this triangle here. I'm gonna split the line. Let's split the triangle. Does one of these look like a trapezoid? If so, comment down below if it's left side or right side. Did you have any diabilities? You mean disabilities? Well, I honestly don't know that one, but I don't think I have a disability. So, I keep asking, but I don't have a disability. So here is point A. This is point B, point C, point D, point E. Okay, so let's just say this one is 11 inches. This one's 11 inches. This is 6 inches. 6 inches. Okay. So AB is 11 inches. Divided by BC, which is 6. So 11 over 6 is equal to A over E, 11 inches, over E over D, 6 inches. So 11 over 6 equals 11 over 6. What did I do? I just asked, do you have a disability? Yeah, I don't have a disability. Yeah, I don't have a disability. Sorry. Yeah, I just don't have a disability. Okay. Okay, I think that's the only vocabulary word I know of as of right now. Is that advocate who told me, yeah, you should not be having arguments in a chat. So, yeah, you should not be doing arguments, okay? Okay. So, I'm ready to give you an example. Using the triangle proportionality theorem. Okay. Oh, I know. Wait, what? It's me, Zach Arts. Okay. Now I think I know some of you. I apologize. I don't know what to call it. So, if anyone is in geometry, put a comment down below so that I know. Thank you. So, for example, okay, so let's see. In triangle PQR, segment ST is parallel to RQ. If PT is equal to 7.5 MTQ is equal to 3 and MSR is equal to 2.5, find PS. Huh? Body now. Sorry. Okay, so speaking of what's behind me, there's nothing scary behind me. Oh boy. Oh boy. Okay, so we're gonna show our work. Wait. So we know all of this, right? So we know about these measures right here. So speaking of which, we have to identify what this angle is. This thing is. So let's do MPS divided by 2.5 is equal to 7.5 divided by 3. Well, in that case, you kind of have to multiply one of those by 3. Huh? Oh, no. No new comments. So, let's do 3 MPS divided by 3 is equal to 18.75 divided by 3. Then MPS is equal to 6.25. And you know what the thing donated 6,000. Okay. This is like so crazy. Yeah, so here's the triangle. Well, I'm gonna divide this here. So this is S T P Q R. It doesn't truly matter what letter you use. Okay? It doesn't truly matter. So this is 2.5. This is 3. This is X. And this is 7.5. Okay. Okay. So. Okay. So if we figure out if 6.25 is actually x. Would that be our unknown? It should. So, okay. Here's another term. Okay, so now we're going to deal with the converse of this term that I taught you. So with this term, it's the converse of a triangle proportionality theorem. So instead of me just writing it out, I'm just going to tell you what it is. So, the converse of triangle proportionality theorem. No. If a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then a line is parallel to the third side of a triangle. Just going to stretch it out. Okay. Log. So, speaking of which, C, D, B, E, A. I think. Okay. So if segment AE is equal to CD, then the segment A, the line A to C, the points A to C, will be parallel to the line of set points E and D. Okay? And speaking of which, if you're, well, the points of B and E are the same exact distance between points B and D. Okay? So, let's see. Okay. So we're going to find an example of that. Well, maybe not. Okay. So here, something's, yeah. So, okay. So let's see. So we have a triangle, and we have a big triangle connected. I'm going to erase this triangle here and show you an example. So this triangle, okay, I'm going to do like this, here. We all call this a triangle, right? So what if we do other triangles? Okay, so one point touching here. We have two, well, we have one triangle still. Because we have a triangle and a trapezoid. And then we have another line touching from here to here. We have two triangles now. One of them is a rhombus. So, Haystack arts. Okay. And then we have another line connected from here all the way down to here. We got four triangles. So how on earth could we possibly get four triangles from one big triangle? Well, we have one triangle inside of this triangle. And so now we have 1, 2, 3, 4. 4 triangles. This is what geometry people call mid-segments of a triangle. And you know what that is? Well, it's a segment with endpoints that are the midpoints of 2 sides of a triangle. How are you? I'm doing good, Zach. Thank you. Oh, yeah. So, speaking of which, we have another triangle thing. Okay. But this time, we're going to be dealing with what? Right triangles. Okay. You know triangles like 90-degree angles? Okay. So, now we have here, then here, here, we have 90-degree angle. Okay. So, well, let's see if we could do here. Well, now what is that called? Triangle mid-segment theorem. So, this is points K, G, H, J, F. So, a triangle mid-segment theorem is a mid-segment of a triangle. It is parallel to one side of a triangle, plus, and its length is 1/2 the breadth of that side. Like, geometry is wording about triangles and 3D shapes and 2D shapes. So including area, perimeter, everything else. So, speaking of which, we're almost 28 minutes, or we're nearly 28 minutes through the thing. Okay, so now we have an example. Other than those 2 vocabulary terms that I didn't even write out because I could just teach without me writing down the whole entire word, its whole entire definition. Okay, so this one has 2 acute angles and 1 obtuse angles. So, here, here. And apparently, people call this the obtuse. It's 124 degrees. Okay. Well, that kind of looks like it. Right. So that's much better. So now I have 13. Okay, so in the figure, the lines between points X and Y and X and Z are mid segments of triangle RST. Find X, Y and XZ, Y and ST, plus angle R by X. So speaking of which, well, we need to find the length of that angle right there. So So, here, okay. So XZ is technically the same thing. So you just have to divide 13 by 2, which we get 6.5. So speaking of which, why do we get 6.5 from dividing 13 by 2? Well, that's true. So, want to do yearbook? Let's do yearbook R. Wait, what? Did I say RN? Yeah, so how are you? Want to do yearbook? Let's do yearbook RN. Okay. Okay. So, MST. Sorry if I cracked my voice. So, this apparently says that it's at 17. It kind of looks like a 77. No. Yes or no? Okay. Well, sure. Let's go for it. So, speaking of which, well, let's test to see if this is. Oh, I don't think that's 180 degrees. So that's where my handy dandy protractor comes in hand. So 150. So 150. So we're going to subtract 150 minus 124. We got 26. So this side must be 26. This side must be 26. This will be 124. Wait, this is not true. So this would be 56 because supplementary angles have to add up to 180 degrees. So why are we doing this if we don't even know that it equals 180? Well, that's when I check work. So how I check work is that I would subtract 180 by, no, sorry, by 124. Well, wait, yeah, oh, here. Okay, so 80 minus 24 is 56. 110. So that would be 56. So, according to my trusty protractor, from here over here is 150 degrees. So 24 plus 26 is 150. Okay. So, speaking of which, I have quite a couple of terms. Proportional parts of parallel lines. So, if 3 or more parallel lines intersect 2 transversals, then they cut off a transversal proportionally. So, this. Okay. So, here is something that I keep in mind. So, if you, yeah, sometimes I do geometry in math. So, and speaking of which, I teach geometry first period. Huh? Okay, 2 people. Okay. So, apparently, it's 3 straight lines. Can you where I see those 3 lines? So if you do, comment yes. If you don't, comment no. So, oops. I picked that one too far. That. Here and here. Well, apparently this is A, B, C. And it says E, F, G. Okay. And apparently, this is geometry. Geometry has algebra. Lots of it. So, that's where kind of I come into hand. So, for those of you who are still watching, continue to watch. Thanks for liking and subscribing. So, angles A, B, and C equal to angles D on E, F, G. Or it's called CBA or GFE. I know. Okay. So, I think we have one more term. And then congruent parts of parallel lines. So let's see how we managed to get through this. So if three or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every single transversal. Okay? Every single transversal. So, speaking of which, let's test this out. Okay. Huh? Oh my god. Please no 6-7 in the comments. Thank you. So, let's see. Okay, let's see. Well, if it cuts off like this, well then, if it goes like this, then I'm guessing we're okay. So we have finally one more example before we're going to be done with the whole entire lesson, okay? Okay. Okay, 7 likes. Okay, thank you. So I'm a math mastermind, particularly. So, even though I still go to school, which I should be, I never miss a day. Oh, that occurs rarely if I ever miss a day. So, find X and Y. So this is what I call algebra. So here is what it says. So, J, K, L, B, M, P, Q. Okay. It says, for this one, 6x minus 5. And then it says 4x plus 3. And then on the bottom, it says 3y plus 8. And then the other one, 5y minus 7. But we must find x, and we must find y. So why are we finding x and y? Because x and y are the most common variables in algebra. Okay. So I'm just going to tell you this because I have to check on something. Okay. So x is going to be 5, y is going to be 7.5. Okay? So thanks for watching. Like and subscribe. Bye. This is Sebastian from Sebastian Simon's Mathematics. Today, we are going to be doing Algebra 1. I know, it's only 4:30 in the afternoon. I know. I don't normally do live streams after 12 p.m., but in that case, I kind of have to. So, today we're going to be doing sections 4, 5, 6, and 7 for Algebra 1 video. Yeah, I put on a video for my students to watch. Wow. Okay. So it's exponential functions, top 10 must knows. And the YouTuber is Jensen Math. Jensen Math. So I am going to be teaching you how exponential functions work. Okay? Okay. So let's get to working. So okay, so here is the equation. For some reason, y equals ab to the power of k times x minus d plus c. I think this is one of the formulas that we're trying to give out. So, speaking of which, okay, one moment. I'm back. Just had to get something real quick. So, speaking of which, okay, so here are real functions. This is the must know number 4, which is section 4. Oh. They're just graphs. So, a is greater than 1, or a is less than -1. BS, then I think FO A. With these bars mean absolute value. Okay. Ava is the greatest. Okay. This. Can you give me a shout out? Yes, I'll give you a shout out. Are you special means? Are you special needs? No. No. I'm not in special education. Sorry, but I do teach online. Mainly for the first 4 years before I actually go to college. Practically. So you were born stupid? No! Oh my god, no, I'm not. I wasn't born stupid. No. I was born smart. Practically smart. But I don't teach calculus. I only teach Greek. I thought someone opened the door. Oh, no. I said special needs like autistic. Yeah, I'm not gonna talk about that. Thank you. You're not gonna talk about my life. So, okay. So this inequality -1 is less than A, less than 1. BC, BAFO. I do not know why BAFO is used. And then absolute value of A. Huh. Okay. If C is greater than 0, then it goes up. Okay, so C is greater than 0. Down. Wait. Okay. So here's something that I need to show you. Okay, never mind. So, I am going to be planning a special giveaway / shout out when I reach 1,000 subscribers, I think. So if you are interested in a shout out, comment down below, okay? okay is greater than 1, or is less than -1, HC both 1 divided by absolute value of k. This is pretty crazy. So if -1 is less than k is less than 1, HS both 1 over absolute value of k. And then also, k is greater than 0, HR. So if D is greater than 0, then it goes right. So if D is less than 0, it goes left. So it goes up and down. So you sort of know, as they call ROIs. And these are what we call X's. Okay? Okay, so here is one example. Make sure you pause and record when we're done. When I'm done recording or something. Okay. So graph G of X equals -2 times 1 over 2, then X minus 3 minus 2. Okay. One moment. Okay. So here, so A is equal to -2 versus BAFO 2 and BR -2y. Taking notes. D is equal to 3. Right 3 units. X plus 3. And now C equals -2. Down 2 units. Y minus 2. And so Y is equal to 1/2 X. So now we're going to deal with the X's and Y's. I have -2, -1, 0, 1, 2. What do you think Y's are going to be? Okay. So, so it'll be 4, 2, 1, and half, 0.25. Okay. So now we're going to add all the x's by 3. So what if we take x plus 3? X plus 3. And then on the right hand side, we have -2y minus 2. So we have negative 2 plus 1. What's negative 2 plus 1? 1. What's negative 1 plus 3? 2. What's 0 plus 3? Obviously 3. Where's 1 plus 3? 4. Then 2 plus 3 is 5. So now, negative 2 times 4 is negative 8 minus 2. That would be negative 10. Then underneath would be negative 6, negative 4, negative 3, negative 2.5. Okay. Okay. So now we're done with section 4. Now we're going to do section 5. Here we are doing section 5. Section 5 is something that we all might not even notice even a little bit. So section 5 is called the inverse of exponential. Okay. So the inverse is like the opposite of doing something. So if we take the inverse of addition, then we get subtraction. If we do the inverse of multiplication, then we get division. So how can we identify the inverse of exponential? We find the opposite of it. So I'm going to have you think for just a moment while we do some notes. One moment, sorry. Okay, I'm back. So now we're going to learn a new mathematical term. So so if f of x is equal to b to the power of x, then f to the power of -1 times x is equal to log b, and then to the power of x. Or just x, whatever. Okay, x. So it's technically algebra 2 here. So what are we doing for this log thing? LOG mathematics. So this is what we normally use. So a log function finds the exponent to which the base must be raised to make the a equal to the argument. Like, what are we even talking about arguments if we're doing mathematics? Well, you mean statements? Well, sure. Well, what if we take okay, so the exponent to which the base must be raised to make it equal to the statement. That makes more sense. So, here is the formula. So, y is equal to log b x is equal to b to the power of y equals x. Does that make sense to you all? Algebra is algebra. Learning new mathematical terms equals learning new mathematical terms. So, like, how can we explain what we're doing to find this log thing? Yes, that's a B, not a cursive S. If you're all seeing that. If that works like a 6, I'm sorry. So, here's the example. 5, 2. Which is another word for example. So, log 2, then 8. And then log 3, 9. Well, apparently to this, can you see that right now? Okay. So, okay. I'm gonna have to bring my phone here for a moment. Okay. So this is equal to 3. This is equal to 2. So, like, okay. So, like, how are we figuring out what log to log and then subscript and then parentheses like a number? Well, this one wasn't on a thing before, but it's log 100 and well, you know what it is? 2. Okay. So now we're going to be doing an evaluation. So you are going to solve this problem. 5 to the power of x equals 20. I do not know why I'm not having comments. Okay. Guess I'm guessing we're gonna have to wait. I'm back. So apparently, we have to find log 520. And I don't think he might be ready for this. But it's actually x equals 1e86. Like, how is that possible? Or how is that possible? So, speaking of which, we just write it as 1 to the power of 86. And that's it for segment 5. Solving exponent equations. Well, some of these are going to be algebra 2 type stuff. So, here's 6a, here's 6b. So 6a is telling us 27 to the power of 2x minus 5. Like, how is that even in a mathematical term? So, and the other one is, okay, shoot. Hold on. 9 to the power of x plus 1 equals 27 2x minus 5. The other one says 5 to the power of x plus 3 equals 7 to the power of 2x plus 1. Like, how on earth is that even possible? So that's when the work comes in handy dandy dandy. I do not know what it means. So okay, so let's do the easiest one first, which is the first one. We're already 30 minutes in, so let's move on. So it says 3 squared x plus 1 equals 3 cubed 2x plus minus 5. And then it'll be 3 and 2x plus 2 equals 3, 6x minus 15. Like, you have to multiply the power with the exponential equation. So Speaking of which, okay, so now these cancel out, leaving 2x plus 2 equals 6x minus 15. So now we have 2 plus 15. We're getting one set of terms on each side, making this one negative, so that cancels out. This swaps to the other side, so now I have 6x minus 2x. So that's 17 equals 4x. Then we divide both sides by 4. X equals 4.25. Like you just had to cancel out the base. Now this is getting crazy now. So it says log then 5x plus 5x plus 3 equals log 7 2x plus 1. And now we have to distribute both. X plus 3 times log 5 equals 2x plus 1. Wait. I accidentally wrote minus 1. Sorry. Log 7. Now I have to take x log 5 plus 3 log 5 equals 2x log 7 minus log 7. And now we're taking 3 log times 5 plus log 7 equals 2x log 7 minus x log 5. Oh, we have one more thing. Okay, so 3 log 5 plus log 7 equals this full equation. So it's x 2 log 7 minus log 5. This is going wild right now. Okay. So, do you want to know the full answer? Because I'm not doing any more of this. So the answer for 6B is x equals log 125 plus log times 7 divided by log 49 minus log 5. Okay. So you know how I said that I'm going to be able to do sections 4 through 7. Well, I think I kind of had a lot of running, but I'm going to give my brain a break for today. So, thanks for watching. Make sure that you like and subscribe. And have a good day. Bye. I'm Sebastian from Sebastian Simon's Mathematics. And today I'll be teaching my students and you guys, if you're participating, in the scientific notation and powers of two lesson in like an hour and 40 minutes, 83 minutes. So, okay. So, just as a reminder, you need to have a number that is like less than 10, but greater than 1. Okay, so let's like this little app. Must have a base less than 10, but greater than 1. Okay. Are you 42 and 3? Okay, good. Okay, so you must include 10 to a power, whatever number stands out to the number. Okay, so let's do an example of scientific notation. So first, estimate 1,653,200,000. That number in scientific notation. Okay, so already 2 minutes in. Bing. Huh? Yeah, we're already 2 minutes in. Bing. So make sure that you like and subscribe. And make sure that you like and subscribe to my channel. Okay, thank you. So, how can we estimate this number in scientific notation? Well, we could count how many zeros it has for that number that's on my whiteboard right now, and calculate how many zeros it has, and calculate its full value. Because you must include all the numbers on a thing. Okay. Speaking of which, okay, so we're going to count all of the zeros. So, like, how many zeros do you see? Like, a lot. I bet. So, I count the zeros, usually about 3 values. So, 0, 3, 6, 9, 12, 15. 15 zeros. So, this number equals 1.6532 times 10 to the power of 15. Or oh, nothing. Okay. So, speaking of which, make sure they comment down below if you are wondering about this. So today we're going to be doing scientific notation and then doing powers of 2, like squared numbers, like to the exponent of 2. So, like, speaking of which, this is scientific notation right here. Okay? Okay. Okay. Here's a number that's already in scientific notation. Estimate 3 times 10 to the power of 8. Okay. So I calculate how many zeros it has. So, starting at 1 0. Making 2 0. 3, 4, 5, 6, 7, 8. And we stop there. And then we added 3. See? That's what you use standard form and in scientific notation. So this is going to be what scientific notation is all about. Scientific notation is about exponents, powers of 10, and so much more. I can't even imagine. So, speaking of which, do you want to try it? Okay. I'm going to give you like a couple minutes. Okay. Scientific notation. Like order. Okay. So estimate all of this. And some of the numbers already in scientific notation. Okay, so problems 3 and 6, you need to find the number in scientific notation. But remember, it's not going to be less than 10. Well, it's going to be less than 10, but greater than 1. Okay? You have 5 minutes to work on this. And then if you're all familiar with the scientific notation, then we are going to move on to another lesson already. Oh yes, there's going to be a word problem too. Yeah. Okay. Actually, we're just going to give you like 1 minute to work on all of this. Well, do you want to actually work for the rest of the class? Okay. We're going to be going over this thing as a class now. So, this is equal to 30,000. Then 4,500,000. But then 1.003 times 10 to the power of 5. And then 3,470. Then 340. And then 3.4749356 times 10 to the power of 8. Okay. So thanks for watching. I hope you have a really good day. I'll see you in about 15 to 20 minutes. But it's going to be the same class, okay? Bye.